call this greener than green. We can not only utilize a coal ash that would otherwise be landfilled, we can then build out energy storage with that. That allows us to essentially minimize over 95% of the core materials.
This is Energy Cast, and I'm Jay Downhauer. Today we are talking about gravity-based energy storage, creating a mechanical solution that doesn't require natural geography. You know by now I'm a huge energy storage supporter. It's critical for renewable energy and could help smooth out the baseload traditional energy sources as well. Last year you heard my pumped hydro episode in Virginia, where two lakes with 200 feet of elevation difference have provided customers with the world's biggest battery. But what about regions that are vertically challenged? I'm from Louisiana. I don't think I saw anything that could be conservatively called a mountain until I was 14. My guest today has a solution for that. They've developed a tower crane design that raises and lowers blocks. The crane sticks out 6 directions and controls the blocks like a giant marionette.
I got no strings to hold me down, to make me fret or make me frown.
These blocks are huge, about 35 metric tons each. When the system is storing energy, blocks are lifted and stacked into place. When it's time to make some energy, the blocks are lifted and dropped down below. Sometimes as many as 4 blocks are in motion at a time, kind of like those thwomp characters from Super Mario World. My guest says the software is the key driver and was critical to the success of the system. You'd imagine a crane operator would be needed. Oh no, my guest says that would be far too complicated, especially when you factor in the amount of energy the grid requires, sometimes megawatts at a time and sometimes only a fraction of that. Plus, the software guarantees a soft landing for each brick, unlike the bad guys Mario had to contend with. Now this may be the deepest cut I've ever done on this podcast, but the software management of the 6 cranes remind me of a cartoon I once saw growing up. You remember Alf?
Anybody home? Anybody home? Ah! Kill me.
Yeah, that one. There was a Saturday morning cartoon that took place on Alf's home planet Melmac, and in one episode it was revealed that a robot down in the center of the planet spent all day pulling levers to ensure it didn't spin out of orbit.
Hyperbolic flow okay?
Hyperbolic flow, okay.
See, I speak his lingo. Hi.
At one point in the episode, Alf messes up and one of his buddies has to temporarily take over this robot's job. Hijinks ensue.
Hang in there, Rico! We'll have this straightened out in no time!
My guest's software operates like that robot, ensuring all the blocks in the system are moved in perfect harmony. We also discuss an important issue that you might have caught in the cold open. Rather than fabricate these blocks off-site, my guest says they bring the brick-making facility to the site, eliminating the need for potentially thousands of truck trips. The blocks can be made from surrounding soil or from waste products like coal ash. It's all part of their greener than green philosophy, creating an energy storage solution that benefits renewables and traditional fossil energy sources alike. My guest today is Rob Piccone, co-founder and CEO of Energy Vault, an energy storage company based in California and Switzerland. The company has been around since 2017 and is just beginning commercial operations. I heard about the company twice. The second time was from a coworker who knew I was into these kinds of technologies, and the first was from an audience member during one of my speeches at PowerGen last year. I thought he was talking about Vault, which develops flow batteries. You can understand the confusion. Now that I've got it straight, Energy Vault prides itself on being the world's only cost-effective utility-scale gravity-based energy storage system that is not dependent on land topography or specific geology underground. I hope you enjoy my conversation with Rob Piccone. We're here with Rob Piccone, co-founder and CEO of Energy Vault. And Rob, I like this design because you'd think the elements are already there. The crane technology, the generators. What are you developing that's new for this application?
Well, actually, quite a bit. We had to solve for a lot and innovate, which is why something like this has not been done before. And primarily, Jay, on achieving an economic point where we wanted to come to market with something, when you take the storage cost combined with low-cost wind or solar, you could actually be competitive with fossil fuel. Because of that, we had to innovate for quite a bit. The software side, it's got some predictive intelligence aspects, computerized control, and some AI that essentially automates the whole process of the charging of the tower and the discharging of the tower through the lifting and lowering of these massive composite bricks. In the bricks, that's another one of the innovations. To achieve the cost point, we couldn't use concrete. We actually don't need the compressive strength of concrete. These blocks are holding up the blocks above them. They're not supporting any horizontal load. We worked with Cemex to come up with a composite, a way to essentially make, let's say, 95, 96% of this brick from even the soil. We can use that same technology for waste materials that otherwise would have to be landfilled or disposed of that can hurt the environment if they're landfilled. Concrete debris to coal ash. We wanted something that could be deployed now. And we leveraged proven technology, but in a way that between the software and the material science innovation allows us to essentially make this product all localized at the site while leveraging the supply chains of others. We have tower cranes that are made all over the world. We have motors and inverters from the likes of GE, Siemens that have been made for many, many years. We've already dug out the foundation. We use that soil at a minimum if there's no waste materials to make the bricks. Our brick machine shows up on site and makes it locally. There's not hundreds of trucks that are bringing in materials that create emissions in the atmosphere.
I didn't even think that the blocks would be a special technology, but this design, and especially when you see the animations, it really captures the imagination. What gave your team the idea for this concept?
Sure. My co-founder, Bill Gross, looking at different technologies, Bill called me and had a concept in and around gravity storage. If you look at pumped hydro, so gravity storage, it's 95% of all energy storage today. Mm-hmm. But we wanted to take some of the negatives of pumped hydro and then try to get to the cost point. Some of the negatives are the environmental aspect, the cost, they're billions of dollars. They're still too high cost as a storage mechanism if you're trying to be competitive with fossil fuel. In addition, the round trip efficiency typically is about 70%. So you're losing through the pumping up of the water about 30%. And we didn't want to be restricted where you could deploy this. I think if you look at the other gravity storage technologies that rely on a topology or a geology below, they're very difficult to fund from an investment piece because it's hard to scale. That's how we then got to something that was very difficult in the final iterations, Jay, to take different iterations of these cubes of a tall cylinder that could be built, but that was too expensive. That was of concrete or steel. That's too expensive. We had trays of water in a cube.
Yeah.
So we looked at that, but that required pumping of the water again. So that's how we ended up. And through creative material science and other aspects, we got to the cost point.
Were you out driving around one day, looked at a crane lifting up something heavy, and he was like, was there anything like that? That draws energy. I bet if you strung it out, it would generate energy.
It's interesting. When you think about gravity, obviously you need height or some levels that you're solving for it and using weight. One of the innovations here was the concept of stacking. This was the eureka moment. Some companies that use just single monolithic cube blocks, you'll never get the economics. That was the real aspect in sort of rethinking how you might think about lifting a single weight to multiple weights and then introducing the software.
One of the biggest things about renewables and anything that you want to try to put on the system that's storage related is you want to draw energy intermittently, but pay out that energy smoothly. Can the blocks draw energy intermittently as they need to? And then as energy needs to be consumed, blocks will be lifted accordingly?
Absolutely. I mean, if you're going to do an energy storage, you have to be able to deal with the dynamics of supply and demand, what's coming in from the grid or coming in directly from solar or wind. We can essentially charge at different and variable rates. We do control the speed, and typically this system, we can fully charge a system in about 8 hours, and then we can discharge that in a variable way. We have a standard discharge that works basically at about 2.9 meters a second of drop, about 10 kilometers an hour, but that can be altered, and there's a reason there are 6 arms of the crane. You have 4 always moving. We're going to be discharging up to maximum 5 megawatts of constant power. That that can be varied. For example, given we have long duration, we can distribute or discharge 35 megawatt hours of capacity. So that means that the customer could configure it to discharge during, for example, the early evenings when demand is high. We could maximum discharge. But as you get to 9 p.m. and beyond, you can throttle that back to as low as 500 kilowatt. And the way that's done is not only the speed, but the software you can set up both dynamically and you can preset it up. For example, contracts independent power providers may have with the utility. And the last thing I'll point out on that, we obviously aren't just dropping the bricks free. It's a controlled movement. It is constant. There is a deceleration that takes place when you're placing a brick. That's offset by an acceleration on the other bricks that are being picked up at the top of the tower and lowered. This is all compensated through software.
Yeah, so you're able to get a constant rate of energy production.
Absolutely. Yeah, it was fundamental to the design.
6 arms, obviously not a crane operator. Is this manned at all in any capacity?
No, it's fully autonomous.
Yeah.
Essentially, this is monitored locally, and we monitor them as a part of our maintaining of the system from a central regional location. The only thing fundamentally that's needed is there's scheduled maintenance with the crane and the motors, for example, that would take place at annual intervals with different schedules.
One of the things I was thinking about with the animation was you're stacking these blocks pretty high. How do you ensure that the blocks don't gradually get off center the more you restack them? Now, I'm picturing dominoes or Jenga blocks. Eventually, you stack them high enough, they're going to tilt one way or another. So do they interlock?
Yeah, by the way, it's a great question, especially you've seen the video. So you look at that and it's a tower. I mean, it is a building. The design of the brick is special. You're absolutely right. There is an interlock and a special sequence that we stack the bricks in. In addition, and this is not in the public videos, there is actually a crossing mechanism. I'm sharing this with you because we're building these systems now, so people are going to see them. There's a full external shelter. In addition, in the middle of that shelter, there's basically a cross. There's bricks that get stacked in essentially one horizontal and one vertical. That helps with some of the security. And this was fundamental. We worked with Caltech, who invented the Richter scale, by the way, and with UC Berkeley and utilization of a shaker table as well to test and look at the seismic analysis to look at the impact of earthquakes. And very interestingly, the fact that these bricks are not connected with mortar and the fact that they can shuffle a bit during high and a long duration seismic activity actually is better.
That's amazing. Yeah, that's wild.
I mean, it's you wouldn't think about that, but there's actually a very interesting branch of science that's been a bit opened up here. What we've been able to prove and not only predict with the software and to see it live on a shaker table is withstanding an earthquake up to 8. But obviously the structural integrity, the safety, this is paramount. And that's why these systems aren't manned. So if there was a natural disaster that would impact not only this tower, but probably a lot of things, there's a safety zone around the actual footprint. So if there were to be any issue, there would be no risk to life.
I'm always talking about things being built robust. You know, I came from oil field. Everything had to be tough. Tower cranes, this technology is really modeled off of those. They're not designed to stand indefinitely, but what you're designing, what you're suggesting would stand for decades. So what have you been working on to make sure the design is robust enough to essentially stay out there indefinitely, as opposed to tower cranes, which, you know, they get finished building a building, they come down?
Yeah, by the way, another great question. We share a similar background. I worked for Amoco, you might remember, and then British Petroleum after the merger back in 1998. So I spent the first 7-8 years of my career building chemical plants, and obviously with a lot of tower cranes. One thing to point out would absolutely be correct if this was a standard tower crane, and this is a little counterintuitive, but standard tower cranes have to be erected and dismantled often. Because you have to dismantle them, you have to build them in sections that can be dismantled and transported. Our design does not require the amount of interlocking mechanisms that a typical crane would require because we're building a stationary storage object with stationary crane. Because of that, we actually have a much more secure design on the core mast or tower section of the structural steel because we don't have to build this to be erected and dismantled all the time. This enables us to build a more robust crane because of its application for 25, 30 years, it should be there. And then your second point on things like the cables and the motors, et cetera, these are things that have been made for many years. There's standard schedules. This is obviously operating full time. We have intervals, standard maintenance done annually, and then every 5 years or 10 years, there may be some replacements of some specific motion components or rotating components that have wear. This enables us to achieve a very low OPEX, well below a percentage of CAPEX, which is well below anything else in the market. And that, of course, enables a levelized cost because our storage doesn't degrade over time, unlike batteries that degrade immediately with cycling. We have zero degradation. That's why we can get so low that combined with wind or solar, we're competitive and even below the cost of fossil fuel.
The utility industry is dealing with challenges finding a home for their legacy coal ash. This is happening everywhere. I'd assume you can make a lot of the blocks from that ash, correct? I think they'd be interested in taking the ash and making blocks out of it.
Sure, absolutely. And this was, as I mentioned a bit earlier, fundamental to our design concept of the utilization of waste or remediated materials. It is really not only a huge innovation, but it's fully unique to our storage. There's no other storage methodology where we could utilize these types of materials in the way we can. This is a focus area for us, given what's happening all over the world. You saw the announcements in Germany where the government's going to spend 44 billion euro to support the transition from coal over time there. And obviously in the US with some of the mandates that have come from the States. But in addition, you're seeing this with very large consumers of energy, Google, Amazon, these very large companies that are actually requiring that their power come from renewable technologies. But absolutely with the coal ash, this is something, if you think about this, and I call this, Jay, greener than green as an approach, because we can not only utilize a coal ash that would otherwise be landfilled at a significant both financial cost and environmental cost, we can not only use 100% of it to make the bricks, we have the compressive technology to make them, but we can then build out energy storage with that. The utility or their energy company that has that coal ash liability doesn't have this huge sunk cost of multi-billions of dollars, but they're actually investing in energy storage so they can take that money that they otherwise would have been a large expense and build out renewable generation, offshore, wind, solar, and then they have the storage infrastructure made with that ash. So you talk about beneficial reuse and this concept of circular economy, which again was fundamental as we looked at this design. It's one of those things we're really excited about.
You touched on something earlier about the blocks, and I didn't even think about this, but you're building thousands of blocks. So you construct the blocks on site, because the alternative would be hundreds of truckloads transporting these blocks to wherever you're building one of these towers, right?
Absolutely. And I mentioned this about the innovation of scalability and supply chain. And this is an area of innovation and supply chain strategies for a lot of companies now, is factoring in sustainability to how they build specifically to minimize transport. That is part of both the localization aspect of this, where we send a brick machine to the site, and whether we're using the soil or the coal ash or any local materials, that allows us to essentially minimize and eliminate, in some cases, over 95% of the core materials. We do prefabricate a higher quality concrete for the base plate of the brick and the upper top plate, because these bricks are going to be setting on top of each other. And over time, we want to eliminate some of the wear and also deal with the seismic analysis. We want these bricks to shuffle a little bit if they have to.
We're a little later in the interview, but give us the high level statistics. How much energy can be produced? How long? How efficient?
Sure. We can, in a single system, go up to 80 megawatt hours, and it depends on the height that we're allowed to build it at. We use 35 megawatt hours as our standard system. In that type of a unit, if you're just going to fully discharge at max output, you're going to go 4.5 megawatt for 8 hours. That'll consume the 35 megawatt hours. In terms of efficiency, we're coming to market achieving a round trip efficiency of 82%, and just slightly above that is where we expect to be, somewhere between 80 to 84% out of the gate. And through some very interesting innovation with special polymer cables to reduce friction, as well as working with some of the largest motor and generator manufacturers in the world and looking at differences, for example, in asynchronous and synchronous motors. Our target is to get up to 90% in the next 2 years round trip efficiency. So that means we're only losing about 10%, which is as competitive as any storage technology out there. And on an economic side, we targeted and achieved to get to market below 5 cents a kilowatt hour on a levelized cost basis, which pumped hydro is somewhere between 15 to 20 cents. A lot of the chemical batteries today are north of 20 cents. And obviously those costs will come down over time. Because the main thing is we need all the innovation we can get. I'm the biggest supporter of all of the storage technologies, honestly, that can meet the environmental standards. So that's a high level operating parameters.
Cool. The animations show one block dropping at a time. This is where my brain went. What about large energy draws and releases? Can you speed it up, or are you considering configurations that would pull up big rings rings of blocks at a time?
Yeah, we obviously didn't put in the public domain everything, but fundamentally anybody that understands physics and how tower cranes work, you have to have that balance on that single arm that is really two arms, right? So it's the full diameter length of that arm. So there are two blocks being moved. You have to have that balance. And there's a reason there's four arms that are always moving. You have six total arms, so that enables the output capacity. And to your point, obviously we're already moving multiple bricks. There's configurations, and I won't say it's something we're looking at. We have configurations that do move blocks of multiple bricks, and they're specifically designed for certain types of applications that I won't get into here right now because this is some of our future product roadmap and innovation. But absolutely utilizing, instead of, for example, a rotating crane, a bridge crane or a gantry crane for applications where you want to have a covered structure, for example, where there's snow. We have an interesting portfolio you'll be hearing more about.
I'm sure that we can imagine a lot more configurations once we get the basic up and going. And again, Rob, you bring up a great point, which is something that I've been talking a lot about, and I'm a big storage supporter, and I really like to keep the message going beyond batteries. Whenever people talk about storage, they're thinking of just lithium-ion batteries, and I want to point out that there's so much out there like what you're doing, and you mentioned pumped hydro, and of course compressed air storage and everything like that, and what you're working on has a lot more cycles.
Yeah, absolutely. This is why we didn't consider a lot of the chemical battery technologies. And number two, there's already a lot of investment that is being made in various chemistries and battery technologies. And with that investment and with some very, very smart people are looking at solving those things. And so those things will evolve in a positive way. But there's a lot of different alternatives to solve this problem. Obviously, it hadn't been solved previously. 95% of all storage today is still pumped hydro. Now that's changing. And I think we're going to be one of those companies. Obviously, there's a lot of battery companies that are out there. And I would say that we absolutely need technologies that respect the environment in terms of the sustainability aspect of how materials are brought and produced, how the systems are constructed, and how these systems are utilized over time.
Maybe you can make some of the blocks out of recycled lithium-ion packs or something.
Absolutely. Absolutely.
Okay. Rob, I want to finish with a lightning round of your thoughts on different energy technologies, starting with natural gas.
Much more available, and with the technology helping us be more independent. And it's one of the lowest cost, I think, fossil fuels.
Crude oil.
Similar in a lot of parts of the world, so inexpensive to get it out of the ground. I think that's why it's still one of the fundamental building blocks. Very encouraged, by the way, by the technologies being developed to minimize the carbon emissions during the whole process of not only getting it out of the ground, but in producing it. And I think things like carbon capture, et cetera, this answer will go for a lot of these technologies.
Nuclear.
We've had a few examples in the world that unfortunately resulted in some catastrophic accidents. In terms of risk of the technology versus alternatives, I would like to see us move away from nuclear over time, depending on how secure and safe you can really make the technology. And many countries have exited nuclear and are struggling to look at renewable ways to replace it.
You kind of beat me to this. Coal, and I always add coal with carbon capture.
If we can add technology to eliminate the CO2 emissions from coal production, then I think that technology gives a life to coal. And I think we're going to have alternatives if there's technology that can eliminate carbon emission aspect, or at a minimum get it to net zero. I think we're in good shape.
And getting into our carbon-free stuff, wind.
The more we can deploy offshore and deploy it obviously safely, I'm a big fan of wind.
Solar?
Same comment. In fact, solar, I would say, has much more opportunity given how much sun produces, also solar fuel, to really concentrate the sun and therefore be able to crack water into hydrogen and other elements. Solar is my favorite.
And I'm glad you brought up the concentrated solar variety. We usually always think of PV. I appreciate you doing that. Biofuels.
Today, rely on a lot of credits in order for them to truly reach the economics, but with those subsidies, I think they can be economical. It's just hard to get, I think, the efficiency out of biofuels versus other technologies. However, you've got a utilization of biofuels using, for example, in jet fuel. Big fan of that over other mechanisms that are more severe in terms of their emissions.
Hydroelectric.
I think what has been built, we absolutely should continue to use. I am not an advocate of building out additional hydroelectric. It has in the environmental ecosystems. There are multi-billion projects. They're higher cost, and they don't really move the needle relative to replacing fossil fuel. Over time, I think we'll be building out less and less of those. And by the way, a big part of building a hydroelectric dam is concrete production, which we tried to avoid as much as possible in the production of our composite bricks. Production of concrete produces I think, roughly 6 to 7% of all greenhouse gases.
Yes, not all power plant emissions. Geothermal.
I like geothermal, and I think the key there is harnessing that power with the right technology and even looking at ways to store it. And we're actually in discussions with some customers in some regions and looking at ways that our technology can help store and then be utilized to help distribute and transport the power.
You guys, energy storage.
It is a imperative for the world, energy storage, to make renewables and convert them to baseload power. That is the fundamental aspect that drove the creation of our company, and really, for the first time, in our case, providing 24/7 or baseload power from renewables.
Electric vehicles.
The more we can electrify our transport sector, absolutely the better. As you might imagine, and you'll imagine I'll say this, getting to alternatives to materials versus lithium ion, or looking at things like hydrogen for fuel, but the more we can electrify our transport sector, the better.
I like that you brought up the hydrogen stuff as well. Energy efficiency.
Imperative for economical and scalable technology.
And then finally, fusion power.
Well, look, I'm a big advocate of innovation and never excluding what maybe hasn't been done in the past. And I'm also a big believer in the capability of humankind and what we can harness really globally to solve some of the biggest problems. And that's one that obviously would be a tremendous benefit to the world. We can solve that.
All right, Rob Piccone, Energy Vault, thank you so much for your time.
Thank you, Jay. It was a pleasure.
That was Rob Piccone, co-founder and CEO of Energy Vault, a gravity-based energy storage company. Rob's co-founder, Bill Gross, is also the founder of Pasadena-based Idea Lab, one of the longest-running and successful incubators. Energy Vault also recently announced their Series B funding last August, and we wish them the best. I want to thank Rob for his time, as well as Al Duncan for setting this up. You can find plenty of pictures on energy-cast.com, as well as on Instagram at Host Energy, and now Twitter at Host Energy Cast. All guests are sent the raw and completed audio the week of release. So far, no complaints. Be sure to leave us a positive review on iTunes. That gets the word out. Music was produced by Sean Stroop at Stroop Loops. That wraps up episode 78. Be sure to join us next week when we discuss carbon storage and its many forms with the Department of Energy. Until then, I'm Jay Downhauer. We'll see you next time.